determination of volume of the sphere. Okay, we already know the formula. Look at this. What's the formula of volume of the sphere? 4 by 3 pi r cube. Use this formula and try to answer. Volume is equal to 4 by 3 pi r cube. Then percentage error in present in measurement of volume, delta v by v into 100 is equal to, there is no error in measurement of 4 by 3 pi also. Those values are constant values. Now only error present in the measurement of radius, that is represented as 3 times of delta r by r into 100. What is the error value of in radius? It is 2%. So final answer, percentage error present in the measurement of volume of the sphere is equal to 3 into 3%. Answer is 9%. This is the answer. Which option matches? Oh, sorry. 3 into, this is 2%, right? So they have given 2%. Okay, sorry. I thought they had given 3%. This value is 2%. So it is going to be 2%. Answer is going to be, final answer, 6%. This is the answer. Option D is correct. Very good. Now, let me solve you 11th question. Look at the 11th question. So what is the data that they have given? You can try by pausing it. Okay. Now, the density of a cube is measured by using its mass and length of its sides. Okay. First of all, let me represent that cubical representation. Okay. Let me have a cube like this, whose density is measured in terms of mass and length of its sides. Let's say length of this cube is L. As this is a cube, density formula is mass per unit volume, not unit volume, mass per volume of that cube. Okay. So what about volume of the cube? Volume is equal to L cube. Volume of this cube is equal to L cube. That is length into breadth into height. As this is a cube, all of them are equal. Now what's the question they're asking? Oh, they've already given some more data. Maximum error in the measurement of mass and length are 3% and 2%. They're asking maximum error in density. Okay. So what is the formula for density? Density is equal to mass by volume. I've already represented how to represent it. So rho is equal to mass by L cube. I need percentage error in density. Delta rho by rho into 100 is equal to delta m by m into 100 plus 3 into delta L by L into 100. They've already given percentage error present in the measurement of mass. It is equal to 3%. In length, it is 2%. Let me substitute that. It is going to be 3% plus 3 into 2%. So final answer, it is going to be 9%. Look at the option which is matching. 11th one, option D is correct. Very good. Now, if you observe the next question, the 12th question. 12th question is also of same model. Now, you just guys try by your own by taking a pause. Percentage error in the measurement of mass and speed are 2% and 3% respectively. Question number 11 and question number 12 are mostly they are similar. Okay. Okay. Now, what is the data they have given? Percentage error in the measurement of mass and speed. Error in the measurement of kinetic energy they are asking. Okay. So what about kinetic energy formula? Kinetic energy is equal to 1 by 2 m v square. I need percentage error in the measurement of kinetic energy. Then delta Ke by Ke into 100 is equal to, there is no error in the measurement of 1 by 2 because it is a constant. Then an error in the measurement of mass is delta m by m into 100 plus 2 times of delta v by v into 100. They've already mentioned percentage error present in the mass. It is 2%. In speed, it is of 3%. Then by substituting these values, 2% plus 2 into 3%, final answer I'm going to get it is of 8%. For question number 12, option A is correct. Okay. Okay. Now look at the question number 13. A body weighs 22.42 grams. They have given mass. Okay. M is equal to 22.42 grams and has measured volume of 4.7 cubic centimeter. The meaning of cc is cubic centimeter or centimeter cube. You can represent in a both ways. That means they have given units in the form of CGS. Volume is equal to 4.7 cubic centimeter. This is also can be represented as centimeter cube. Okay. The possible error in the measurement of mass and volume are 0.01 grams and 0.1 cubic centimeter. That means they have given change in the value of mass m, which is equal to 0.01 grams, and change in the value of volume, which is equal to 0.1 cubic centimeter. Now I need to find out maximum error in the density. Okay. What about density formula? Density is equal to mass by volume. I need percentage error. So delta rho by rho into 100 is equal to delta m by m into 100 plus delta v by v into 100. If I substitute delta m, they have given it is 0.01 divided by 22.42. Both are grams, that will get cancelled, into 100 plus delta v is 0.1 divided by 4.7 into 100. If you calculate this, you are going to get answer approximately equal to 2%. So that's the answer. Next, let me get into the next question. Now the next question they have given it is based on significant figures. Okay. Look at the data. So taking into account of the significant figures, what is the value of 9.99 minus 0.0099 meter? Okay. If I subtract 9.99 and 0.0099, the resultant that I am going to get is 9.9801 meter. In addition and subtraction, we have to observe and we have to answer the question. Final answer should be in the form of least number of significant figures. Observe which is having least number of significant figures after decimal point we have to observe. Not after decimal point, try to understand. So final answer you are going to get 9.9801. Now this one is having significant figures 3 and here it is having significant figures 2. Comparing to both of them, so most of the students used to answer to list number of significant figures. But in addition and subtraction, after decimal point, we have to check out least number of significant figures. Now after a decimal point, in both quantities we have 2 significant figures. Then final answer should also consist of two significant figures after decimal point. That means answer is going to be 9.98. Hope you understood. Even though out of these two we have second quantity is having least number of significant figures, we have to reduce it to significant figures, least number of significant figures, that is after decimal point. After a decimal point, if you observe, in both the cases we have same number of significant figures. That is the reason we are reducing it to two significant figures after decimal point. That's the reason answer is going to be 9.8. It is not 9.9. Most of the students used to answer it as 9.9. That's wrong way. Now, question number 15. Question number 15 is based on physical quantities, dimensions of physical quantities. Look at this, the stress dimensional formula. So the formula for stress is force by area. So we know force dimensional formula. Force dimensional formula you can represent, if you cannot remember the thing, you have to convert this in the form of fundamental physical quantities. Force is not a fundamental quantity, it is a derived physical quantity. Then I have to convert into mass into acceleration divided by area is not fundamental. Then I have to convert into meter square. So this is mass and this is meter. Don't cancel both of them. Mass is different, meter is different. Okay. Now otherwise you can write down, just for losing confusion, let me represent this is as length square. There is also a better way to represent length square. Okay. Next, mass acceleration is not a fundamental physical quantity. I have to convert that acceleration into fundamental physical quantity. How can we convert that? It can be represented as m mass into velocity divided by time divided by length square. Still velocity is not a fundamental physical quantity. We know that. Again we have to convert into physical quantity, fundamental physical quantity. Let me write down that formula again. So finally mass into velocity is represented as length by time divided by length square. Now this is completely converted into fundamental physical quantities. If we take that length into numerator, it is going to become length power minus 2. So final answer is going to be mass power 1 length. If it goes to numerator, it will become 10 power minus 2. Already length power 1 will be there. It will become 10 length power minus 1. And we have time in denominator, that is time power minus 1. So final dimensional formula for stress is m power 1, L power minus 1 and T power minus 1. This is stress. Similar to stress, we have same dimensional formulas for pressure also. Pressure is also equal to, we have time square, no? Here velocity by time and one more time is there, so it is going to be time square. So we are going to get T power minus 2. So final answer is T power minus 2. M power 1, L power minus 1, T power minus 2 is the dimensional formula for stress. Stress and pressure dimensional formula. At the same time, modulus of elasticity dimensional formula, all of them are same only. Sir, will it take this much time to answer? Nothing like that. If you can remember force dimensional formula, then it is very easy to answer. See, if you want me to answer in a less time, so stress is equal to force by area. Force dimensional formula m power 1, L power 1, T power minus 2 divided by area dimensional formula is going to be L square. So if you take this to numerator, you are going to get m power 1, L power minus 1, T power minus 2. It is this much easy if you know the force dimensional formula. Otherwise it will take some time. Look at the question number 16 and it is very interesting. Let me explain you each and every option. They are asking the pair of quantities having same dimension. Okay, let me check out each and every option. Option A. In option A, so what is the thing they have given? Impulse and surface tension. Okay. Impulse and surface tension. Formula for impulse is, it is actually represented with change in momentum. Change in momentum can be represented as F into delta T, force into delta T. Force dimensional formula is m power 1, L power 1, T power minus 2. Just now I have explained. Time dimensional formula, T power 1. So finally, impulse dimensional formula. Impulse is nothing but change in momentum. Change in momentum. According to Newton's second law, you can write down this formula. F is equal to dp by dt or delta p by delta t. From that formula also we can answer this. So final answer you are going to get m power 1, L power 1, T power minus 1. This is for change in momentum. Let me check it out for surface tension. Surface tension, see, whenever you observe the terminology called tension, most of the students used to answer, so it is a tension, so it is like a force. No, it is not like that. Surface tension formula is either it is represented with S or T, which is equal to force per length. This is the formula for surface tension. Okay, let me get into it. So it is going to be m power 1, L power 1, T power minus 2 divided by L power 1. So final dimensional formula you are going to get for surface tension is m power 1, L power 0, T power minus 2. Force per length is surface tension. Is these two dimensional formulas are same? No, they are not. So first option is wrong. These two dimensional formulas are not same. So first option is wrong. Okay. Let me get into the next option. What is the next option? Angular momentum and work done. Okay. Angular momentum and work done. Angular momentum is represented with L. Angular momentum is an axial vector. Whenever any particle is moving in a circular motion, we used to represent angular momentum. Not only in circular motion, when it is moving in a curved path also we can represent angular momentum. But it is not in the form of cross product when it is in a curved path. If it is perfect circular motion, then you can represent in the form of a cross product. Formula for angular momentum of a point mass is mvr. Sin theta is also there. Sin theta is dimensionless, we know that. Let me represent dimensional formulas. Mass dimensional formula is m power 1. Velocity dimensional formula is L power 1, T power minus 1. R is the distance of the particle from the axis of rotation or from the center of the circular path. It is represented with a L power 1. So final dimensional formula for angular momentum is m power 1, L power 2, T power minus 1. Okay, let's get into work done. Work done general formula is F into D into cos theta. F into D into cos theta. Let me represent sin theta also here, because some students may be getting confused. Sin theta is dimensionless quantity. Dimensionless quantity. Theta is having units, but it is not having any kind of dimension. Similarly, cos theta is also dimensionless quantity. Now, force into displacement we have. So, work done is equal to force dimensional formula m power 1, L power 1, T power minus 2. And the distance or displacement dimensional formula L power 1. So final answer you are going to get m power 1, L power 2, T power minus 2 is the dimensional formula for work done. Is these two dimensional formulas are matching? No, they are not. So option B is also wrong. The question they are asking is pair of quantities having same dimensions. So first option, second option is not correct. Let me check option C. They're asking work and torque. Okay, torque is nothing but a rotational force. Torque is a rotational force. This is also having another name, that is moment of force. Moment of force. Force which makes the object to move in a circular motion, that or to rotate. Whatever the force which is responsible for rotation is called as torque. Now work done, just now I have explained. Dimensional formula for work done is m power 1 L power 1 L power 2 T power minus 2. Now we have a formula for torque. Torque is equal to R bar cross F bar, which is equal to RF sin theta. It's not P. Be careful with this. So it is R into F into sin theta. Already told, sin theta is dimensional quantity or a dimensionless quantity. It is a dimensionless quantity. So R into F. R is the distance of the particle or perpendicular distance, we used to call it as. So it is going to be L power 1, force dimensional formula m power 1 L power 1 T power minus 2. So final dimensional formula you are going to get m power 1 L power 2 T power minus 2. Yes, option 3 is correct. The dimensional formulas of work and torque both are equal. Let me check Young's modulus and energy also. So you should understand, right? Okay. Option D, Young's modulus. Young's modulus of elasticity, its actual complete name, it's defined as a stress by strain, which is equal to longitudinal stress. Longitudinal stress divided by longitudinal strain. The meaning of longitudinal L is nothing but along the length of the wire. Okay, strain is a dimensionless quantity because it is change in length by original length. For longitudinal strain, I am telling you, numerator is also length, denominator is also length. Meter, both will get cancelled. It is a dimensionless quantity. Which is dimensional quantity? Stress or strain? Strain is a dimensionless quantity. Hope you understood. Because it is change in dimension by original dimension. Dimensionless. Now only thing we have unit is for stress. Just now I have explained stress dimensional formula. So look at this, where it is. Here it is. Stress dimensional formula is m power 1 L power minus 1 T power minus 2. Same formula you are going to get for Young's modulus also. Modulus of elasticity units and stress units both are same. I have already told. So final dimensional formula you are going to get m power 1 L power 1 T power minus 2. Sorry, m power minus 1. M power 1 L power minus 1 T power minus 2. Very good. Next, one more they have given, that is energy. See, energy is nothing but a work done. Energy is nothing but work done. Work done dimensional formula and energy dimensional formula both are same. That is m power 1 L power 2 T power minus 2. Is these two dimensional formulas are same? No, they are not. So option D is also wrong. So which option is matching? Option C alone. So option C is the correct answer. Okay. So don't ask me that, sir, you are taking this much time for answering when I will solve the remaining questions. See, this is for your understanding only. Whatever the time I took here, just to give you a complete clarity on each and every option. That is the reason I took this much time. Okay. Let's move on to the next question. The question is question number 17. What's the thing they are asking? They are asking dimensions of mu naught into epsilon naught whole power minus 1 by 2. So immediately by seeing this question, where if any one of you are preparing for 11th, it is somewhat difficult to answer to this question. Actually, this formula is for speed of light in vacuum. The formula for speed of light in vacuum is 1 by root of mu naught into epsilon naught, where mu naught is permeability of free space. Mu naught is permeability of free space. and whereas epsilon naught is permittivity of free space. Permittivity of free space. This terminology comes in charges and fields and magnetism chapter. Permittivity of free space. Epsilon naught is related with the electric field. Mu naught is related with magnetic field. If you write down this formula, C is equal to mu naught epsilon naught whole power 1 by 2. That means whatever the question they have given is for speed of light. Speed of light is nothing but velocity. Velocity dimensional formula is same as speed of light. Then what is going to be dimensional formula for speed of light? It is going to be L power 1 T power minus 1. That's all. These kind of things they used to give just to confuse you or to make you feel difficult. That's all. Okay. Let's move on to the next question. So it is 1 by 2 epsilon naught E square. This formula is actually energy density. So what's the formula for? This formula is for energy density. Okay, let me solve that. The meaning of energy density is, the mass density is mass per volume. So energy density is going to be energy per volume. So what's the question they're asking? They're asking dimensional formula. Okay, we have to check out. Now what is the energy dimensional formula? Energy is nothing but work done, right? M power 1 L power 2 T power minus 2 divided by volume dimensional formula L power 3. So final dimensional formula you are going to get M power 1 L power minus 1 T power minus 2. If this L power 3 goes to numerator, it will become L power minus 3. So final answer you are going to get M power 1 L power minus 1 T power minus 2. This is the answer for 18th question. Let's get into next 19th question. So look at the data they are asking. If the dimensions of physical quantity are given by M power A, B power, L power B, T power C, then physical quantity. Okay. Now in this case also, let me explain you each and every option. Velocity. So what is the formula for, dimensional formula for velocity? Velocity dimensional formula is M power 0 L power 1 T power minus 1. That means here A is equal to 0, B is equal to 1, C is equal to minus 1. Is it matching? No, it's not. So this option is not correct. Sorry, not this formula is correct. We have to check out dimensional formula is correct. We have to check out whether this one is matching the given data or not. So first option they are given velocity A is equal to 1. No, it is not at all matching. So this is wrong. Next option. Next one is acceleration. Okay. So what about acceleration? Acceleration is velocity by time, right? Velocity by time is nothing but length by time. It is going to be length by t square. You are going to get M power 0, L power 1, T power minus 2. This is the acceleration dimensional formula. A must be equal to 0, B must be equal to 1, C must be equal to minus 2. Look at the option 2. Is it matching like that? A is 1. Okay. Sorry. It's not at all matching. So this is also wrong option. So whatever the answer I got, it is not matching with the options. That's the reason I'm telling you that is a wrong answer. Okay. Let me get into option C. Force. We know that force dimensional formula. M power 1, L power 1, T power minus 2. Now here A must be equal to 1, B must be equal to 1, C must be equal to minus 2. Check out. A is 0. No, first line itself, it is not matching. So it is wrong answer. Next. So whatever the answer which is left, that is correct only. Let me check whether it is going to be correct or not. Next, pressure. So pressure is nothing but a stress. Now I've already mentioned it earlier. So it is also represented as F by A. F by A is nothing but a stress dimensional formula. That is M power 1, L power minus 1, T power minus 2 actually. It means A equal to 1, B equal to minus 1, C equal to minus 2. Yes. Last option is matching. So last option is the correct answer. Okay. Let me solve question number 20. So what's the question they're asking?